पैरेलल सर्किट्स. इन AC circuit अभी तक हमने क्या पढ़ा? Series circuit. Now we have a parallel circuits. In parallel circuits we have two branches A, B, C, D. In branch AB, a resistor R1 is connected in series with inductor L. In branch CD, resistance R2 is connected in series with the capacitor C. So, let the impedance of branch AB is Z1. So, branch AB, what is the impedance? Z1 is equal to R1 plus JXL. What is XL? XL is equal to 2 pi FL. What is the current in branch AB? I1. This I1 is equal to this voltage applied V divided by Z1. Power factor at the angle is phi 1 between the voltage and the current. So cos phi 1, that is equal to R1 upon Z1. Similarly, for branch CD, what is the impedance in this case? Z2 is equal to, we have a resistance R2 minus JXC. What is XC? XC is equal to 1 upon 2 pi FC. What is the current I2? I2 is equal to V upon Z2. And the power factor cos phi 2 is equal to R2 by Z. Right? Now, these are the impedance, current and the power factor of the branch AB and CD. Now suppose we have to find the current I. What is I? I is equal to I1 plus I2. यही देखा अभी तक आपने DC सर्किट में, but in AC circuit I is not I1 plus I2. I is the vector sum of I1 plus I2. Okay, you can't get the value I, that is I1 plus I2. So to find the I1 and I2, let us draw the phasor diagram of this. Okay, कहां से स्टार्ट करेंगे? You can start the V. What is I1? I1 is the current which is lagging behind the voltage because it is a inductive part. So this is the I1. And what is this angle? This is the phi 1, what we assume here. In this branch CD, I2 is the current which is leading by an angle of phi 2. Why it is leading? Because it is having a resistor and the capacitor. So this is your current I2. Because these two are the vector quantities, that's why we can't get the value of I, that is equal to I1 plus I2. So we have to find out the vector sum of these. Okay, क्या कर सकते हैं हम लोग? We have two methods to find out the current I. In the first method, we resolve this I1 and I2 into x-axis and the y-axis. Okay, this is the method we know. So to find I, what is I cos theta? That is equal to I1 cos phi 1 plus I2 cos phi 2 is equation number 1. I sin theta is minus of I1 sin phi 1 plus I2 sin phi 2. Now we have these two equations. To find I, क्या करेंगे हम लोग? You square the equation 1, square the equation 2 and add. क्या हो जाएगा? I square cos square theta, I square sin square theta. तो sin square theta, I square sin square theta plus cos square theta. So this is 1. तो जो वैल्यू आ रही है उसको हम क्या कर देंगे? ऐड करके, इन दोनों का स्क्वायर करके ऐड किया और उसका अंडर रूट ले लेंगे. दिस वैल्यू इज I. टू गेट द एंगल थीटा, that is tan inverse, the value of equation 2 divided by the value of equation 1, this will give you the angle theta. There is the first method. In the second method, I is equal to under root of I1 square plus I2 square plus 2 I1 I2 cos of phi, where phi is the angle between the I1 and I2. So we have these two methods to find the current in parallel AC circuit. Okay. Let us start with an example on parallel circuit. A 60 ohm resistor is connected in parallel with an inductor having a inductive reactance of 80 ohm to a 240 volt supply. Calculate the current through the resistor and the inductive reactance. Second, the supply current and the circuit phase angle. Okay. So this is a resistance which is connected in parallel with the inductor. This is 60 ohm, a resistance of 60 ohm, inductance 80 ohm. They are connected in parallel, right? So what is the IR? IR is the V upon R. So V, voltage 240 volt divided by the resistance. So you will get 4 ampere. IL means the current flowing through this inductor. V divided by XL. This is 3 ampere. Now find the supply current. For this, we draw the phasor diagram. Okay. In this phasor diagram, we are taking V as a reference because this V is common to both this. Now, the current is in phase with voltage. Current flowing through the resistor. So they are in phase because we know that in pure resistor circuit, the voltage and current are in the same phase. IL is lagging behind the voltage by 90 degree because in inductive circuit, the current is lagging behind the voltage by an angle of 90 degree. So to find I, क्या करना होगा हमें? I, that is equal to under root of IR square plus IL square plus 2 IR IL cos. What is this cos? This is the angle between the IR and IL. What is this? This is 90 degree. So you will get 4 square plus 3 square. क्या हो गया? 16 plus 3 plus 9, 25. So you will get 5 ampere. This is the current you will get. Now, the circuit phase angle. Circuit phase angle means this angle. Okay. So to find this angle, this is the circuit phase angle. To find the angle, this phi, tan phi is equal to IL by IR. IL is 3, IR is 4. So you will get phi is equal to tan inverse 3 by 4. So this is the angle 36.87. So this is our first example. Okay. A parallel circuit consists of two branches, one having a coil of resistance 5 ohm and inductance of 38.2 millihenry. The other branch, non-inductive resistance of 16 ohm in series with a capacitor of 300 microfarad. The circuit is connected to 240 volt 50 Hz single phase supply. Find the current in each branch, total current, circuit impedance, circuit phase angle, component of an equivalent circuit. So, कैसा सर्किट हुआ आपका? This is your circuit. It's 5 ohm. It's 38.2 millihenry. This is 16 ohm. And this is your 300 microfarad. Suppose this is I1, this is I2, this is IE, and this is the voltage. So क्या क्या दिया हुआ है आपको? आपको दिया हुआ है 5 ohm, 38.2 microfarad, 300 and 16 ohm. You have to find out the current in each branch, means I1 and I2, total current I, circuit impedance, you have to find out the Z, circuit phase angle theta, and the component, means यदि इस सर्किट का टोटल इंपीडेंस निकालने के बाद जो भी आएगा उसका इंपीडेंस में जो कंपोनेंट्स लगे हुए हैं उनको आपको कैलकुलेट करना होगा. ओके, R1 is 5 ohm, L 38.2 millihenry. So what is XL? 2 pi f L 12 ohm. Z1 under root of R square plus XL square. Okay, so 5 square 12 square, you will get the 13 ohm. I1 V upon Z1. V is 240 volt is given. Z1 is 13 ohm. So this will give you the 18.46 ampere. What is the power factor? Cos phi 1 R1 by Z1. So this is the 0.384 lagging. Why it is lagging? Because it is a inductive part. So from here you will get the angle 67.38. In the second branch, we have a resistance of 16 ohm and a capacitor is connected in series with this. So what is X? C here, Xc is equal to 1 upon 2 pi Fc. Okay, so you will get 10.61 ohm. So Z2 is under root of 16 square plus this square. So Z2 is 19 ohm. Current I2 is equal to V upon Z2. So 12.5 ampere. Cos phi 2 R2 by Z2 0.833. It's leading because now the branch is capacitive. So from here you will get the angle 33.56. Now draw the phasor diagram. We will take V as a reference. So we have the I1 which is lagging with an angle of 67.38. I2 it is leading with an angle of 33.56. Now to find I, क्या करना होगा हमें? We have to resolve this I cos of theta I1 cos phi 1 plus I2 cos phi 2. Find the total current. We resolve this I1 and I2. This V I1 I2. We resolve this. So I1 cos phi 1 plus I2 cos phi 2. I1 is 18.48, cos phi is 67.8, I2 12.5, phi 2 is 33.56. This is 67.58 and this is 33.56. when you solve this, you will get the 17.52. I sin theta is minus of, क्या होगा, minus I sin phi 1 plus I2 sin phi 2. When you simplify this, you will get minus of 10.13. So total current I is the vector sum of this I1 and I2, and you will get 20.24. Circuit phase angle. This theta is tan inverse minus of this divided by this. जब हमने डेरिवेशन किया था तब आपको याद होगा, ने बताया था थीटा इज इक्वल टू tan inverse value of equation 2 divided by value of equation 1, right? So here theta is equal to tan inverse this 30.49 minus, because हम तो क्या होगा, इसका मतलब क्या हुआ, वो लैग कर रहा है. नेक्स्ट इज द इम्पीडेंस ऑफ द सर्किट. इम्पीडेंस Z is equal to V upon I. V is the 240 volt divided by this current, आपको कितना है, 20.24. So we will get Z is equal to 11.86 ohm. Equivalent resistance of the circuit R, that is Z cos theta, it's 10.27 and XL is 5.94. Why it is XL? Because the current is lagging. It means the total performance of the circuit or the behavior of the circuit is inductive. So in this way we can solve the parallel circuit problems.